is we're going to take a look at the basic template that we use for our NEMA starters and for our IEC starters. And then we're going to take a look at how we can configure some very basic circuitry using 2-wire method and 3-wire method. The 2-wire method is essentially utilizing what we call as low voltage release. And then 3-wire is about low voltage protection. So we want to make sure that we can incorporate those in a basic sense. So when we look at this right up here with our NEMA starters, the top line here is going to be our NEMA starters. We'll see that we've got the 1, 2, and 3. The 1 is where our supply is coming from, and again, we're just looking at the control stuff. Everything else is pre-wired in the starter itself. We don't need to do anything. So they're super handy in that regard, but they're limited in the fact that they're really only for one thing. We can have some play with them, but then when we get down to the IEC, and the reason why I use the ish is because we're actually kind of manipulating this, and we're putting the IEC numbering system, and we're laying it out like we would in a regular NEMA schematic diagram, ladder schematic, because real IEC is actually kind of like on its side and it goes from top to the bottom. But it's the basics of using the IEC numbering system in a ladder diagram that we're used to. So just to make more sense to us. Okay, so we're going to start out with our NEMA one. When we talk about the 2-wire control, we're really talking about just utilizing the release. It's now something that we're going to use for our pumps or something like that. Something that when the power goes out and the power comes back on, we want it to turn back on again. So like sump pumps, refrigeration units, air conditioning, heating systems, stuff like that, where we can't afford to have to push the reset button again. So we're going to utilize just terminals 1 and 2. So I'm just going to use this real quick, and I'm going to just pencil in something. And I'm going to use a blue here just to kind of give us an idea of what we could sort of see. If we wanted to use just a regular single pole, single throw switch, we can. Super easy peasy. We can turn it on, we can turn it off. That is now putting it into manual control. If we wanted to do something a little bit more advanced, we can. We can now incorporate, I'm trying to use my pen here now. If we wanted to incorporate something like a thermostatically controlled switch. Now we're talking about an automatic pilot device. It's now responding to something other than just my finger turning it on and off. Okay, and I'm still using just terminals 1 and 2. And I'm not using the holding contact at all. I'm going straight to that starter at terminal 2. So now I'm going to go and I'm going to look at what I can do here for a 3-wire control. The 3-wire control now really just allows us to incorporate that protection feature. So when the voltage becomes too low, it's going to drop out and it's not going to keep that motor energized. So now I'm going to go across here and I need to have, well, let me even just go back. Okay, so I'm just going to engage something here. Our regular start, momentary push button, and I'm just going to incorporate here now with our NEMA 1 and 3 and 2. Seems pretty simple. Now when I push that button down, I have a current path that's going through here, energizing that, closing my contact. Easy, but I can't turn it off. So what I'm going to have to do is I got to incorporate something in here so I can turn this whole thing off. And that's where we want to incorporate a stop and a start in here. Now, again, when we get into more advanced controls, we're just going to be replacing what we're using here as our normally closed, normally open push buttons. And I'm just going to put in more features in there. I'm going to use automatic pilot devices. I'm going to put more of them in there. So the very basics that we want to look at is right in here. And this is our, what we would call our stop area. Right up here, we're going to call that our start area. And right under here, we're going to call that our holding. Again, all we've used is terminals 1, 2, and 3 to engage into our 3-wire control. I can change out these devices from push buttons. I can put them to any kind of control device I want. I'm just going to have to play around with that a little bit to get the control that I want to get. Okay, now moving down into our IEC-ish, all we would need to do with the IEC-ish is, if you look at what's happened down here, I'm just going to go up to the NEMA here. I've taken my overload, and in NEMA, the overload is on the right-hand side, is where we see that. And we're looking at a series component, so it's going to be able to de-energize that whole thing. But we have something that regular code, Canadian electrical code, doesn't like. It's not de-energizing as we're coming into the circuit. So IEC is a little bit more advanced in that regard. It's now going to make us put to our overload devices first, but they're not pre-wired in. We have to know these terminals. So when we're making the connections in the field, we have to be careful of the numbers and the numbering systems that we're using. We label our conductors, and we're going to be very careful. Okay, so from line 1 to 95, and then from 95, if we're doing our 2-wire control, I'm just going to go across here and install whatever kind of device that I'm going to use for control. And I also have to make sure that I'm going to connect and complete my circuit. I'm going from the A1 to A2. Again, we have to do all of the connections in an IEC starter. We'd have to make those. So now I've got a complete working 2-wire control, and what's missing out of this is our holding contacts. That's the type of control that we're looking for in our 2-wire system. Again, I can change out that single pole, single throw switch, and I can put in anything, thermostat, pressure switch, limit switches, anything that I want. Okay, now I go over here to my 3-wire control. Again, I'm going to have to actually wire from my L1 to my 95, and from my 95, I'm going to have to, and I got the same choices. I have the same areas that I had in our NEMA control. I'm going to have a stop component in here. So I'm going to wire in my device that I want to be able to stop or open that circuit. And I'm going to have to wire in. I'm going to use this a little bit different here. I'm going to use a float switch this time, just to change it up a little bit. Now I can turn that circuit on, but as soon as that level drops, now it's going to turn off automatically to utilize a full-on 3-wire control circuit. I'm going to need to make those connections right there. So I'm going to have to run that conductor from number 14, terminal 14, to A1. That is in the starter, but I need to make that little chunk of wiring in that starter. And then up here, I would need to run 3 wires out to the field. Okay, a minimum of 3 wires out to the field. Okay, that's the difference between our 2-wire and our 3-wire control in a schematic sense, but we want to get comfortable with these numbers. So please make sure that you've looked at the numbers and you've tried to write that down, draw that out a few times, is the best way for you to be able to remember this and to be able to apply it when we get to the labs or you get out into the field, because we want to make sure that we're using the right terminals that do the right function for us.